Hello dear students, this is your Professor Lázaro Pino, and now we are having solutions and electrolytes. In this part also we will learn how to determine the concentration of a solution and, what is more important for a nurse, to use the dilution formula. What is exactly a solution? Well, the components of a solution are the solute, that is the dispersed component, and the solvent, that is the component in which the dispersion occurs. We have different types of solution: gas into gas, gas into liquid, gas into solid, and so on. And here you have some examples that you can read carefully later. The solubility rules were used by us before when we were studying the net ionic equations, and we observed that all common salts of the group 1A elements as sodium, potassium, and lithium cations, and also ammonium, are soluble, always. All common salts containing acetate or nitrate are soluble. All the halogens like fluorine, chlorine, bromine, etc. are soluble except for those of silver, mercury, and lead that are non-soluble. All the compounds containing sulfate are soluble except for barium, strontium, lead, calcium, silver, and mercury. And all the compounds except for group 1, rule 1, all the compounds that contain carbonate, hydroxide, or oxide, and the phosphate are insoluble except for the ones with the cation in group 1. The general rule of solubility says that likes dissolve likes. What does it mean? That a polar solute can be dissolved in a polar solvent and a non-polar solvent in non-polar solvents. Non-polar solutes in non-polar solvents. Then, here you have some common polar solvents: water, acetone, methyl alcohol, and some common non-polar solvents as hexane, diethyl ether, and toluene. Remember that we have studied before how we can determine that a compound is polar or non-polar. What is an electrolyte? Well, any substance that produces ions when dissolved in a solvent, that usually is water because it's a universal solvent, is an electrolyte. And it is the electrically conductive solution that must be present for corrosion to occur. The types of electrolytes can be strong, weak, or non-electrolyte. How can we determine this? Well, in the lab we use the bulb test. This bulb has 2 electrodes and is connected to a battery. If you introduce the electrodes into a solution and the bulb is very bright, it's because it contains 100% of the ions of the solute, and then ions conduct electricity very well. But if the solute is in form of molecules, then molecules don't conduct electricity and the bulb is not bright at all. We have here that between strong electrolytes and weak electrolytes, we have weak electrolytes. Which one are them? Those that are partially ionized. Then we have a lot of molecules and certain amount of ion that can conduct electricity, and then the bulb is bright but not so bright as in strong electrolytes. Here you have a question. Which of the following reactions represent the dissociation of a strong electrolyte in water? In this case, the answer is C, because in the products you have only ions. This compound is completely ionized. Well, the amount of solute that can be dissolved in 100 grams of water is known as solubility. The solubility changes, as you can see in this curve, with the temperature. Solids, when the temperature increases, can be dissolved more and more in water. Then the solubility increases as the temperature of the solution increases. In gases is the opposite. When the temperature increases, the solubility decreases. But in solids and liquids, we have this behavior. All the solutions that can be represented on this curve are known to be as saturated. What does it mean? That they cannot admit more solute to be dissolved. And if you observe a solution like this, you can observe that certain amount of solute is not dissolved. These are saturated solutions. The unsaturated solutions are those that are below the curve, and they admit more solute to be dissolved. Then if you add solute and the solution dissolve it, it's because the solution is unsaturated. In the other hand, if we have a solution that at certain temperature has more solute dissolved than it can be at this temperature, we say that this solution is supersaturated. Usually we obtain this solution by decreasing the temperature of a saturated solution, and then, for example, at this point, the solution has more solute that can be per this temperature. What is concentration? The concentration of a solution expresses the amount of solute present in a given amount of solutions. How can we determine the concentration? Well, the concentration can be expressed in mass percentage. Is when you divide the mass of a solute by the mass of a total solution times 100, it gives you the percent by mass. The percent by volume gives you the volume of the solute by the volume of the solution times 100. And the mass per volume is when you divide the mass of the solute in the 100 milliliter of solution, or in the volume of the solution times 100, to express this in percentage. The molarity is another way to express the concentration. In this case, is the moles of solute that can be dissolved in a liter of solution. Be careful with the units of the volume in molarity. For example, if we have 10 grams of a salt and 70 grams of the solvent, we have 80 grams of the solution. And we want to find the percent of this of the concentration of this solution. Then we divide 10 grams of solute by 80 grams of solution times 100, and it gives us 12.5%. We have here another problem. If we have 600 grams of sodium chloride and it is 40%, you can find out the amount of solute by mass in this solution. Well, you know that in 100 grams you have 40 grams of solute because it's 40%. Then, if we have 600 grams of solution, how many grams of solute we can have? Then using a proportion, you can get the grams of solute, in this case sodium chloride, in 600 grams of solution. An example of these problems are here. You can stop the video at any time and you can solve these problems. But let's stop in molarity. How can you get the molarity of a solution? Well, dividing the moles of solute by the volume of the solution in liters. Here we have an example. If a concentration of a solution is 2 molar, what does it mean? That you have 2 moles in 1 liter of solution. If the volume of water in the solution is 200 milliliter, then what you have to do? Well, in this case, you have to calculate to convert the moles of the milliliter of solution into liter. You know that in 200 milliliters divided by 1,000 is 0.200 liter. That's the volume of the solution that you have to use. Then, if you have that the mass of sodium hydroxide is 16 grams, and you know that the molar mass of sodium hydroxide is 40 grams per mole, you can get the moles. In this case, dividing the 16 by 40 grams per mole, you get the number of moles. And then you divide moles by liter of solution and you get molarity. This is a way you are supposed to solve a problem like this. Then let's go to the following problem, dilution. Dilution is an operation that is very important for a nurse because you come from a lower volume and a higher concentration to a bigger volume with less concentration. You can use the dilution formula where the concentration 1 times the volume 1 is equal to concentration 2, volume 2. After you add the solvent to dilute your solution. Here you have a problem. For example, if you want to prepare 200 milliliter of 0.300 molar copper sulfate by using a 1 molar solution, what is the volume that we have to take from the first concentration to prepare the diluted one? Well, the volume that you have to take is 0.3 molar times 250 milliliter divided by 1 molar solution, that is a concentrated solution, and you get the volume of the concentration solution that has to be taken to fill the volumetric with more solvent and to dilute the solution. In this case, it gives us 75 milliliter. If we had before 250 milliliter, how can we get how much water you have to add.